Hello everyone, welcome to the next video on DC to DC converter design. In this DC to DC converter design, again we are going to design a buck boost converter. In the part 1 video, we have also designed a buck boost converter with the different specification. Now we will design with the different specification. So here a DC, a 100 volt DC power supply means a source voltage is given as a 100 volt, uh, connected to the load of 750 watt 75 volt means output voltage here it is a 75 volt. So keep in mind here V0 is less than Vs, so obviously it is going to do the buck operation, but we have to design the buck boost converter over here. Okay, so keep in mind, and output power requirement is the 750 watt. Okay, so what are the specifications given? Peak to peak inductor current is limited to 1 ampere. Means what? Whatever the average current through the inductor, the peak to peak variation in the inductor current, this delta IL should be 1 ampere. Okay, so the current through the inductor must be in the dead band of 1 ampere with the average value of the IL. Okay, then peak to peak output voltage, so voltage across the capacitor, that is the voltage across the output, the VC voltage must, if this is the final value of the V0, that which is equal to 75 volt in this case, maximum variation allowed in this peak to peak ripple which is allowed in this problem, it is given as delta VC is equal to 200 millivolt. So first understand the given data, that is equal, it is equal to 0.2 volt. Convert this is into volt, so 0.2 volt. Switching frequency is 50 kilohertz. We have to determine the rating of inductor, capacitor, switch and diode. Also draw the circuit diagram showing all the ratings. Okay, so this is the requirement. Now let us calculate first duty cycle. So duty cycle is equal to V0 upon Vs plus V0 in case of buck boost converter. So V0 is 75, source voltage is 100, and output voltage is 75. So 75 divided by 175, it comes to 0.4286, that is 42.86%. That is the duty cycle. So please see here output voltage is less than the source voltage, so obviously duty cycle must be less than 0.5. So here you can observe the duty cycle is less than 0.5. So because it is a buck operation, if it is a boost operation, duty cycle will be greater than 0.5. So let us calculate the load current. So load current is equal to 150 upon 75, that is 750 upon 75, because output power is a 75, output voltage is the 75, output power is 750 watt, and output voltage is a 75 volt. We know that P0 is equal to V0 into I0, so I0 is equal to P0 upon V0, so that is 750 by 75, it comes to 10 ampere. Now let us calculate the inductor current. The inductor current, current through the inductor is equal to I0 upon 1 minus D. So I0 value is a 10 ampere upon 1 minus 0.4286. So that current is coming to 17.5 ampere. So such a large value of the current is flowing through the inductor, almost 7.5 ampere greater than the load current. Now let us calculate the ripple in the inductor. So ripple in the inductor current is given in the problem itself, because it is 1 ampere, it is given in the problem. So you can see here in the given data, the ripple in the inductor current which I have shown here, it is ripple in the inductor current is equal to 1 ampere. So maximum allowable ripple is 1 ampere, whereas voltage ripple is the 0.2 volt which is given here. So similarly, so inductor current I have taken it is a 1 ampere. Now let us calculate the inductor value. Inductor value is equal to Vs into D upon Fs into delta IL. So Vs is the source voltage, that is 100 volt. Duty cycle is 0.4286 upon 50 into 1, because IL value is 1 and frequency 50 kilohertz. So obviously answer will come into the milli. So the answer is, sorry, I have a printing mistake here. The answer is 0.8572 millihenry. Okay, so this is the answer, or you can say 857.2 microhenry is the value of the inductor. Now let us calculate the capacitor ripple current voltage. Capacitor ripple voltage is given in the problem itself, that is the 200 millivolt, that is 0.2 volt. From that, what is the value of capacitance? Capacitance is given by I0D upon Fs into delta Vc. The I0 value is a 10 ampere. Duty cycle is a 0.4286. divided by 50, that is the frequency is in kilohertz, into 0.2. So whatever the value of the capacitance, it will appear in the milli, because 1 upon kilo is equal to milli. How it is calculated? 1 upon 10 raised to 3. It will give you 10 raised to minus 3. So 10 raised to minus 3 is nothing but a milli. So that answer will directly come into the milli format. So 0.4286 millifarad, that is 428.6 microfarad is the value of the capacitance. So the inductor current which we got here, inductor value which we got here, it is 857.2 microhenry. And what is the current through the inductor? The current to the maximum current to the inductor is equal to IL upon delta IL by 2. So IL value is 17.5. Okay, 17.5 plus delta IL value is 1 ampere, so 1 by 2, so it comes to 18 ampere. Okay, so the value of the inductor current is 18 ampere. So while designing the inductor, we have to take this into consideration, the rating of the conductor which is used to wound, which used to construct the inductor. It must have the current rating of 18 ampere. Now capacitor voltage, the value is coming as 428.6 microfarad, and what is the voltage variation is V0 plus delta Vc by 2. So V0 voltage is a 75 volt, and Vc is the zero point 0.2 volt upon 2, so it comes to 75.1 volt. 75.1 volt. So that needs the value of the capacitance. So let's come to the switch rating. So how to decide the switch rating? In a buck boost converter, the switch rating is equal to Vs plus V0 plus delta Vc by 2. So we know that in the buck converter, the voltage across switch or rating of the switch must be greater than Vs plus delta Vc by 2. But in the boost operation, the voltage across switch is greater than V0 plus delta Vc by 2, but in the buck boost converter it is a combination of this. So Vs plus V0 delta Vc by 2. So Vs value is the 100, V0 is a 75, plus delta Vc is equal to zero point 0.2 volt divided by 2. So it comes to 175.1 volt. That is the answer. Okay, how to calculate the current to the switch? The current to the switch is equal to IL plus delta IL by 2. So IL value is 17 ampere, delta IL is 1 ampere, so 1 by 2, it comes to it is a 17.5 ampere, 17.5 plus 1 by 2, it comes to 18 ampere. So see here, IL value is the 17.5 ampere. Now similarly, diode is also rating of Vs plus V0 delta Vc by 2. So diode voltage must be diode should be selected such that the its value must be greater than 175.1, and the current is greater than 18 ampere. The rating of the diode, this is requirement. So let us write down the switch rating. The switch rating is minimum requirement rating is 175.1 volt with the current of 18 ampere. Similarly, diode is also 171.1 volt and the current is of 18 ampere. So we have to choose the diode and MOSFET such that its rating must be greater than this. Then only the circuit will be sustained. Otherwise, circuit may burn out. Okay. So what is the Vs value in this problem? The Vs value is given as 100 volt. V0 value is equal to 75 volt, and the power is equal to 750 watt. So this is the problem on the buck boost converter when the specifications are given in the ampere or millivolt. So hope you like this video. If you like this video, kindly subscribe my channel, share with your friends, give the likes to my video, so so it will reach to the maximum students or maximum learners. Thank you very much.